you for today's webinar. Our today's topic is powertrain for electric vehicles. Obviously, with respect to the present scenario of EVs, this is the most important topic we can say which every student should know. So, our today's expert is Mr. Sulay Patel, sir. Sir is working as an assistant professor at LD College of Engineering. Regarding the education, I can say Sir has completed his bachelor's and master's in automobile branch, and recently is pursuing his PhD from GTU. And Sir research area is electric vehicle transmission system, and yes, Sir has vast knowledge in this field. And even Sir has 12 years of academic experience. And yes, now I would like to invite our today's experts to enlighten their knowledge to our students. Over to you, sir. Thank you, sir.
Good afternoon, everybody. So let me start with the presentation. Hope my presentation is visible to all of you.
Yes, sir. Visible.
Okay. I am Professor Sulay Patel, Assistant Professor from Automobile Engineering Department, LD College of Engineering. So today we are going to discuss something about powertrain for electric vehicles. So this is the key objectives of today's webinar. The first thing is key stages of EV development, then how electric vehicle works, then we will discuss about electric vehicle layouts, then powertrain for electric vehicle. After that, the main component of powertrain is motors, so we will discuss about motors for electric vehicle. Then motor will draw the power from the battery, and the battery is a storage device which will supply the power to the motor. So we will discuss something about batteries for the electric vehicles, and then we will discuss how we can select electric motor for electric vehicles and transmission systems of electric vehicles. So these are the key stages of electric vehicle development. So I think when petrol and diesel vehicles are not invented, before that electric vehicles were developed and invented in the Scotland in the beginning era of 1801 to 1815. After that, the first stage of electric vehicles were there. Electric vehicles entered the market and start to find broader appeal, because in this particular era, 18 to 19s, I think there is no petrol and diesel vehicles are available in the market, or petrol and diesel vehicles are in very developing stages. So they electric vehicles find the broad appeal in this particular era. After that, boom and bust. So basically in the starting duration of 1901, there is a very boom of electric vehicle. But after the invention of petrol and diesel vehicles, the bubble has been burst for the electric vehicle, because of there are many advantages of petrol engines are there as compared to the electric vehicle which are available at that time. And after in 1901 to 1950s, petrol engines and diesel engines has taken over the electric vehicles. And then after 1951 to 2000, the second age of area, because of the fuel crisis and pollution and all these things are come up with the vast uses of petrol and diesel vehicles. So people are thinking and starting to research about the electric vehicles, and created the new interest to develop a new electric vehicles in this particular era. And after that, in third age, so 2001 to the present, the public and private sectors are now commit to the vehicle electrification, because as you know that the petrol and diesel prices and the prices reach to the nearly 100 rupees, and you can see there's pollution created from the petrol and diesel vehicles are also high. So this is the present scenario that the public and private sectors now commit to the vehicle electrification. So now let's begin with the expected trends in vehicle technologies. So this is the expected trend that from 2000 to this future, with the future aspect, I have made this particular slide that way. You know that the IC engine and transmission innovations and gasoline, all these are going on and on. And one thing is the vehicle weight and drag reduction is also a key aspect for the vehicle design. So it will continue to be a research, but you can see over here from year 2010 to 20, micro and mild hybrid innovations were there, but fully hybrid vehicles are taken over the innovations, and micro and mild hybrid will now innovations are almost completed, and full hybrid innovations are going on right now. After that, you can go up and up there. You can see over here a mass market EV technologies have a best scope for the innovations and research trend over here, and fuel cell vehicles have this also research trends and all these things. So today we are going to discuss these mass market EV technologies and the electric vehicle technologies. So how electrification has been done? So the first thing is the conventional vehicle layout is over here. Here we can say the fuel is there. Fuel will supply the chemical energy to the engine, and engine will convert the chemical energy into the mechanical energy, and that mechanical energy is transmitted to the transmission, and transmission will transmit this power to the wheels. So by in between, it is a combination of electric and the conventional vehicle. So in this particular vehicle, or this is a mid, you can say the mediator between the battery electric vehicle and conventional vehicle. In this particular vehicle, you will find the two types of power plants. First one is a engine, and the another one is a battery. And by hybridization, or means by utilizing the advantage of engines, and by utilizing advantage of battery electric vehicles, we are getting best out of these two and get the power over here. And from that we are going for the battery electric vehicle. Over here you will find that there is no engine and fuels over here, only battery is there, and the motor and generator is there, and transmission is there. So in battery electric vehicle only three major components are there. So now the powertrain which consists of a battery electric vehicle is that battery to the motor and generator, and to the transmission, and from transmission to the wheels. So now let us see about well to wheel efficiency. It means from well, or from crude oil. If we consider that the electricity which is right now producing is only from the conventional power sources like coal and CNG and etc. That so from the crude we are getting this get from the crude we are getting from the well we are getting the crude oil, and crude oil is refining at the refineries, and it is transmitted to the petrol pumps, and from petrol pump or gas stations we are getting this petrol or diesel to our vehicle. So you can see over here the refining efficiency is 82% and transmission efficiency is 98%, and combining of this refining and transmission efficiency is around 80%. From pump to wheels, it is reduced to the 16%. So overall get efficiency which we are getting from the petrol and diesel vehicle, it is a 13% only. And you can see over here there is a major reductions over here, which is a pump to wheels, means the from petrol pump to the wheels of the vehicle, it is a major reduction of efficiency over here. So as compared to this electric vehicle, in the vehicle scenario of electric vehicle, if we think that right now all the in this case we are considering that the electricity which is produced, it is only from the coal, then the generation efficiency is 33%, which is lower over here. But you can see over here that plug to the wheel efficiency is almost 76%. So in this case, we are wasting energy over the heat conversion, and in this thing, we are not wasting there. But in this case, the wastage of energy is over here. So ultimately, at the output, which we are getting efficiency is a 13% in case of petrol and diesel vehicle, and in case of electric vehicle, which is 23%. But if we replace this particular generation system by the non-conventional means, means hydropower station is there, solar power station is there, wind power stations are there. So we can increase this to 40 to 50%. So ultimately, in this by this comparison, we can definitely say that the using of electric vehicle is something more beneficial than usage of petrol or diesel vehicle. Now over here we can see the energy equivalency over here. So this gas means gasoline. So 1 gallon of 1 gallon of gasoline or petrol generates 135 megajoule of energy, and which is equivalent to this much of batteries. So we require 21 lithium-ion batteries to store this much of energy, and the 1 gallon of fuel will weighs only a 2.7 kg. But if we store this much of energy in the batteries, then it will weigh around 340 kg. And in 340 kg we can store 54 gallon of petrol. So main research is right now going on in this particular region, that how to reduce the size of battery, or how we can store more energy in the smaller size of battery. So by reducing the size of battery, we can increase the range. So this major research is going on in the electric vehicle in this particular area, how to increase the range of vehicle, and how to reduce the weight of a battery, and how to increase the battery efficiency. So this is a basic layout of there are different as you know that there are different types of layouts for the petrol and diesel vehicles, like front engine rear wheel drive, rear engine rear wheel drive, front engine four wheel drive. Likewise, let us discuss something about electric vehicle layouts. So first one is a central drive. It is a very simplest layout, absence of clutch and transmission in this, and employed by almost all the BEVs on the market. So over here you can see there is a battery, and battery supplies power to this particular motor, and from the motor we are motor shaft is directly coupled with the fixed single speed reduction gearbox, and from this gearbox power is supplied to the transmission, sorry, differential, and differential will split power to the into the two driving wheels by means of drive shaft. And this kind of central drive electric vehicle layout is consisting in Nissan Leaf integrated e-powertrain, and many more. Almost you can see there is a majority of electric vehicle which consist of battery and motor. All these are runs on this vehicle. Then another one is a wheel hub motor drive. In this case, you can place electric motor is placed inside the wheel hub or inside the wheels, and this kind of electric drive layout you will find in the small capacity scooters and etc. And this can be incorporated in case of four wheelers too, but there need to be complex programming and controller is required in case of four wheelers. So the research is going on in this case, but you can incorporate this in the four-wheelers too. And so this is for the advanced version of wheel up type drivetrains, and the in this you can see this is a motor, then fixed gear and the driving wheels. Again, motor, fixed gears and driving wheels. This fixed gear is reduction gears which we are using because we required a very high torque for the initial traction and tractive force to overcome the static and rolling friction. So the initial single speed reduction gearbox we required over here. So in all electric vehicles, you will see this the fixed gear or a fixed gear train over here. So in this case, in this you can see this the motor and wheel. So in this wheel, you can see there is a motor, and in this particular motor there is a fixed gear ratio. Planetary gearbox is also available. So this has been elaborated over here. Then front and rear wheel drive. So here they have split the electric motors. For the front wheels there is a separate electric motor. For the rear wheels there is a separate electric motor, but the power is supplied from the central one batteries available over here. So this can be capable of front wheel drive, rear wheel drive, as well as all wheel drive. So if we require a front wheel drive, then this system is switched off. If we require the rear wheel drive, then this system is switched off. And if we require the all wheel drive, then the both systems are switched on. Now let us get a brief idea about the high voltage component of electric vehicles. The high voltage components are mainly consist of electric machines, means electric motor or generator, then battery pack, inverter, charger, and DC to DC converter. So here you will find the electric motor. This is the inverter which converts DC to the AC. This is a DC to DC converter, which these battery packs are around 48 volts or 240 volts DC. But for the accessories and other purposes, we require 12 volt DC. So this particular DC to DC converter uh, will convert the 240 volt or 300 watt of DC to the 12 volt DC. And this is a charger and this is a battery pack. So the electric machines converts so the purpose of this electric machine is to convert the electricity to the torque to move the vehicle. There are many different designs, but very simple terms, they are utilize opposing electromagnetic field to create a torque. At least one field is created by current through a wire in the stator, and the second field can be created by the permanent magnets or a second wire pathway in the rotor. The torque is controlled by varying current flow. Now, you can see all the majority we are getting the maximum efficiency, as in previous slide the well to wheel efficiency we have discussed at around 78% or 70% energy is converted from chemical energy to the mechanical energy by means of electric machines. So because of this reason only, that all electric machines are nearly running on this particular higher efficiency range. So electric motor efficiency are often well above 90% and are thus significantly more efficient than the engines whose peak efficiency is down near 40%. Of course, that means no free heat of our cars in the winter. So we means in the electric motor also provides torque at zero speed, which allows one to design a vehicle with a single ratio between the electric motor and the then the multi-speed transmissions. So this is the biggest advantage of electric motor, that it has a maximum efficiency and it can generate maximum torque from the initial starting speeds. Now let us discuss about electric machine and motor. Some engineers and even researchers are mainly consider EV motor kind or similar to the industrial motors. However, EV motors are usually require frequent starts and stops, high rate of acceleration and deceleration, high torque, low speed hill climbing, low torque, high speed cruising, and very wide speed range of operations. Whereas industrial motors are generally optimized at a rated condition. Thus, the EV motor are so unique that they are deserved form an individual class. Their major difference in load requirement, performance specifications, and operating environment are summarized as follows. EV motors need to offer a maximum torque that is a 4 to 5 times of the rated torque of the temporary acceleration and hill climbing, while industrial motor generally offers a maximum torque that is twice of the rated torque of for overload operation. EV motors need to achieve 4 or 5 times the base speed for the highway cruising, while industrial motors generally achieve up to twice the base speed for the constant power operation. Now let we consider electric motor which is designed for the lathe machine. So in case of lathe machine or a CNC machine, we can see this the operation of machining operation speed and the feed and all these things. So there is a very limited speed range as well as torque range for this particular lathe or CNC machine. But in case of car, we can see this the we need to start from the zero, and initially we required a very high torque to overcome static friction and rolling friction. So in this case, we required a very high torque. If we and you can see that all the roads are not at same level. So when we are going for the up hill climbing or at the hilly area, we required additional more torque or very high torque. And obviously, if we want a high torque, then obviously the speed is also low. So again. When we are cruising or we are driving on the highway, so if we want initially high acceleration, then again we required a very high torque. And if we want to drive a vehicle at very high speed, so around 140 or 160 kilometer per hour, then the electric motor RPM is around 12,000 RPM or 10,000 RPM. So, and in case of lathe machine, you can see that the rated RPM of that particular lathe machine's motor is around 2000 RPM or 3000 RPM max. And that lathe machines are also runs on maximum 3000 or 4000 RPM, not that much of 12,000 RPM. So we cannot keep the electric vehicles motor with the normal machines motor. So this electric vehicles motor have some different class or from these particular machines motors. EV motors should be designed according to the vehicle driving profiles and driver's habit, while industrial motors are usually based on typical working mode. EV motors demand both high power density and good efficiency map for the reduction of total vehicle weight and the extension of driving range, while industrial motor generally needs a compromise among the power density, efficiency, and cost, with the efficiency optimized at the rated operating point. EV motors desired high controllability, high steady-state accuracy, and good dynamic performance for the multiple motor coordination, while only a special purpose industrial motors desire such performance. EV motors need to be insulated in mobile vehicle with the harsh operating conditions such as high temperature, bad weather, and frequent vibration, while industrial motors are generally located at fixed place. So again, in this case, you can consider with lathe or CNC machine that the CNC or lathe machine is placed at the one place in the workshop. Or if we consider the CNC machine, then the CNC machine is placed in the very well maintained weatherproof ambience, and it has a very limited range of temperature and adverse atmosphere. But if we consider electric vehicle vehicle, then it can road can be muddy, and with the lots of vibrations are there, lots of heat is available. Temperature at some places the very high temperature is there, at some places very low temperature is there. So there is a very adverse condition for the electric motors. So electric motors should be have a special category from the normal machines motor. So the first type of motor is a DC series motor. DC series motor will provide a high starting torque. It was the most widely used motor for the traction application in the early 900s. The advantage of this motor are easy speed control, and it can also withstand a sudden increase in load. All these characteristics make it an ideal traction motor. The main drawback of DC series motor is high maintenance due to the brush and commutators. These motors are used in the Indian Railways. This motor comes under the category of DC brush motors, and current in the current scenario, people or some engineers are use this particular motor for the project purpose as well as some experiment purpose and low capacity vehicles only. This is a brushless DC motor. It is similar to the DC motor with permanent magnets. It is called brushless because it does not have a commutator and brush arrangement. So in this case, the disadvantage of DC series motor is eliminated. The commutation is done electronically in this motor because of BLDC. Because of this, BLDC motor are maintenance free. So this is a biggest advantage of this particular motor. BLDC motor have a traction characteristics like high starting torque, high efficiency around 95 to 98%. BLDC motors are suitable for a high power density design approach. The BLDC motors are the most preferred motors for the electric vehicle application due to its traction characteristics. So you can see this in the small capacity of two wheelers, in some small capacity of cars and three wheelers and rickshaws. This BLDC motor is very popular and it is very useful, and almost all three wheelers and the two wheelers are equipped with this kind of BLDC motor. So this is a uh, different parts of BLDC motor. So this is a rotor magnets you can see over here. This is a status. This is a stator. So this is a rotating part, and this is a stationary part for this brushless motor. The next one is the permanent magnet synchronous motor, PMSM. This motor is also similar to the BLDC motor, which has permanent magnet on the rotor. Similarly to the BLDC motors, these motors also have traction characteristics like high power density and high efficiency. The difference in that PMS is a sinusoidal back EMF. This is a very key and electrical engineering related related terminologies. But by these EMF control, it is advantageous over the BLDC motors. But in this case, PMS this particular control of this sinusoidal back EM is very complex, and that is why it is costlier. And that is why PMMS is best choice for the high performance applications like car, buses. Despite the high cost, PMS is providing stiff competition to the induction motor due to the increased efficiency and then the latter. PMMS is also costlier than the BLDC motor. Most of the automotive manufacturers uses a PMSM motors for their hybrid and electric vehicles. For example, Toyota Prius, Chevrolet Bolt, Ford Focus Electric, Zero motorcycles, Nissan Leaf, Honda Accord, BMW i3, etc. uses PMSM motors for the propulsion. And you can see over here, these all are the examples in which vehicle this particular PMSM motor is used. And you can see if you want to purchase this particular list of from this particular list, then you need to spend around 45 lakhs or higher. So Disadvantage of this particular motor is right now it is in the current research state, and it is control of this particular motor is very complex, and that is why the cost of the particular for vehicle which equipped with this motor is high. Is only the reason is this control of particular this motor is very complex, and due to this complexity in control, the price of the components which are used in the particular vehicle is very high, and that is why the cost of particular vehicles are high. Now, the three-phase AC induction motor. The induction motors do not have a high starting torque like DC series motor under fixed voltage and fixed frequency operation. But these characteristics can be altered by using a various control techniques like FOC or a variable frequency method. By using this control method, the maximum torque is made available at the starting of the motor, which is suitable for the traction application. Spiral cage induction motor have a long life due to the less maintenance. Induction motors can be designed up to efficiency of 92%. The drawback of an induction motor is that it requires complex inverter circuit to control of the motor is difficult. So these particular induction motors, you can general type of induction motor you can see in the lathe machine or CNC too, and this kind of induction motor is used in the Tata, Nexon, Tesla, all these cars. But the difference between lathe machines and the Tesla is that these lathe machines are normally runs on the and fixed frequency, and in case of Tesla, you can see there is a variable frequency method is used, and this particular variable frequency method is very costly. And the simplest example of variable frequency method is the inverter AC. So you can see that the normal AC is cheaper than the inverter AC. Likewise, that the normal control of induction AC induction motor is cheaper, but the variable frequency control of induction motor is costlier. So there is a little cost is there to control the AC induction motor, but by implementing this variable frequency method, we can achieve maximum power and torque requirement for the initial starting purpose. So Tesla Model is the best example to prove the high performance capability of induction motor compared to its counterparts. By opting for the induction motors, Tesla might have wanted to eliminate the dependency on the permanent magnets. Even Mahindra Reva EO2 uses a three-phase induction motor for its propulsion. Major automotive manufacturers like Tata Motors have planned to use induction motors in their car and buses. The two-wheeler manufacturer TVS Motors will be launching an electric scooter which uses the induction motor for its propulsion. Induction motors are the preferred choice for the performance-oriented electric vehicles due to its cheap cost. The other advantage is that it can withstand the rugged environmental conditions. Due to this advantage, the Indian Railways has started the replacing DC motors with an AC induction motors, and majority of all electric vehicle manufacturers are also planning to use this particular AC induction motor in case for their particular vehicles. So this is all about the battery. This is all about the motors. So basically, there are three motors which are right now currently used in the electric vehicle. First one is a BLDC, that PMSM, and the next one, another one is a AC induction motor. So mid-range cars which are available in India as well as in the all over the world market that uses AC induction motor. High performance cars are using these PMSM motors, and low capacity and small vehicles are use these brushless DC motors. Now let us discuss something about battery packs. So this is a battery pack. The battery pack is the device for storing the energy that moves the vehicle. It must both the accept and provide the current for the electric machine as requested by the driver. The battery pack in the EV is a slave to driver's demand. Hybrid vehicles can use their engine to adjust battery use when the conditions are not proper. So these are the classification of EV batteries. Lead acid battery. So this is a very VRL type lead acid batteries are used in the electric vehicles. Nickel based. So this is a metal hydride or metal nickel based batteries are there. So nickel cadmium, nickel zinc, and nickel metal hydro batteries are used in some vehicles. Metal air batteries, zinc air and aluminum air batteries. Sodium beta, sodium sulfur and sodium NaCl2 type batteries, and ambient temperature lithium, lithium polymer and lithium ion batteries. So these almost five types of batteries are used in the current scenario of electric vehicles. So over here you can see the K parameters of EV batteries, and you can see that that lithium ion batteries are having a maximum advantage or a maximum or the best specifications we get is the lithium ion batteries. But the thing is that the cost of this particular lithium ion battery is much more than this VRL or a lead acid battery. But if we consider a cost with the performance, then the lithium ion batteries are the best suited for the electric vehicles. And basically you can see that the almost in all mid range to the high performance car you will find the lithium ion batteries. In only some cars you will find this the VRL battery or lead acid batteries. Now the perspective on battery pack size in 80 miles of EV. So you can see this the Ford Focus EV, which is around 76 miles. So you can see the size of battery. In Fiat 500, it will run on the runs 87 miles on full charge condition. So you can see the size of battery over here. Chevrolet Spark EV, it runs 82 miles. See the size of this particular battery. Honda Fit EV, it also runs 82 miles. See the size of battery. So as we have discussed that in earlier slides that the size of battery is very high and the weight of battery is also high. So the main concern for the electric vehicle manufacturers and the engineers to reduce the size of battery and the weight. Then we will discuss about the inverter. So in this inverter, in battery packs provide the direct current at their output terminals. Electric machines are controlled by varying and alternating current waveform. The motor inverter provides this conversion between DC and AC and the torque control functionality. So in this case, we can see this the inverter come controller. It is the heart of or a brain of a battery, which can the main purpose of this inverter and controller is to supply a power from the battery to this electric machine as per the requirement or as per the requirement of the driver's input. And basically in this particular battery pack, you can see this there is a DC storage device, and in this electric machine needs the AC. So major function of this inverter is to convert the direct current to the alternating current and controls the power controls and supplies this particle to the electric machines. DC to DC converter. So in this we can see this the power stored is around 48. So in some case it is a 48 volt, in some cases it is a 100 volt, in some cases it is a 400 volts too. And for the to run the AC and headlights and other equipment accessories and equipments we require 12 volt. So what we need to do is that this 300 volt is direct current is converted into a 12 volt. So this DC to DC converter will convert the 300 volt into the 12 volt charger. So in you can see this uh, when we are stop when we can see the fuel tank level is at empty in case of our vehicle, petrol and diesel vehicle. So what we are doing, we are rush to the petrol pump and get filled our fuel tanks, and again we will start our journey. But in this case, what we need to do is we require to search a power supply, electrical power supply, and there is a inbuilt charger. In some cars there is a inbuilt chargers are there. In some cars there is a separate plug for the fast charging and the domestic charging purpose. So EV battery packs must be recharged typically from the electric grid. The charger performs three functions: rectification of AC voltage from the grid to the DC voltage, because battery requires DC voltage; controls the current flowing into the battery pack by controlling the DC output voltage; communicates with the vehicle of vehicle equipment; and bidirectional charge allows energy transfer to the grid. DC charging. DC charging is a phrase that describes the use of an off-vehicle charger. The off-vehicle charger connects directly to the battery, bypassing onboard charger. Robust communication is required between the vehicle and off-board charger. An off-vehicle high-power charger is utilized because high-power chargers are too heavy to justify installation in the vehicle, and so too costly to dedicate to one vehicle. So this is a DC charging, means it is a very fast charging, and due to the fast charging, it requires a very bulky and high power equipments in this case. So we cannot directly install in our car. So basically, what we need to do is we need to take our car to this particular fast charging machine and get charge our vehicle very quickly. So this is a weight breakdown of electric vehicle. So over you can see this the maximum portion, which is around 65%, is weight is off for the energy, or you can say the battery occupies 64% of vehicle weight. Then 27% of the structural and mechanical parts. Heavy motor and heavy electrical parts only take the 4.5% of vehicle weight. Controls and safety is very less, and the thermal is around 1.1% only. So over here you can see this maximum majority of weight of the vehicle is of a battery. So you can see in this particular image to get you can see the most bulkiest part of the vehicle is batteries in this too. Now transmission system of electric vehicles. So generally single speed reduction gearbox are majority used in all the vehicles. In few vehicles 2-speed gearbox are used. In a few in two wheelers you will find the wheel hub motors with the epicyclic gear trains. So this is a single speed reduction. So in this you can see that this is the electric motor, and electric motor is directly connected to the differential with the single speed reduction. This is a open gearbox over here. So you can see that this is the input sub for this gearbox. This input and over here battery electric motor is connected. From this particular shaft, power is supplied to this particular wheel, and it is by means of reduction gear power is supplied to this differential, and from this it is supplied to the wheels. So this is a single speed reduction, and torque which we required at the wheel is very high. So this particular single speed reduction gearbox will convert the low torque of motor to the high torque for traction purpose. two-speed gearbox in Tesla Taycan or Porsche Taycan or one Porsche car electric vehicle is equipped with this two-speed gearbox. So in the the speed of two gears are optimized, like the one for the initial high torque purpose, and the another second gear is used for the overdrive purpose for the high speed. And in this case, shifting of gear is automatically, so electronic control is available for to shift the gears as per the requirement of vehicle as well as driver. This is a simple up drive type motors. And again, there are some chemical engineer and electrical engineers are there who are reducing the size of battery. Few electrical engineers and researchers are working on the reduction of size and increase of efficiency of electric motors. And few mechanical engineers are now thinking about to utilize the multi-speed gearbox, and by utilization of multi-speed gearbox they are going to achieve a reduction of size in the battery as well as a reduction in or downsizing of electric motor. And they are going to achieve the downsize the battery and motor, as well as they are going uh, uh, searching about how to increase the range of vehicle with the downsizing of battery size. So all the research is going on in this particular scenario for the multi-speed gearbox. And if you just Google out, then you will find that the Bosch company has developed a CVT for the electric motor. And a few one Kawasaki and the one high performance bike manufacturer is there. Those have utilized a multi-speed gearbox for the high performance bikes too. So now after a few years, right now you are searching on Google that the electric vehicle transmission, then you will majority find that there is a no transmission, only single speed reduction gearbox is used. So your vehicle is fully automatic with the single speed gearbox. But after a few years, you may be see that there is a multi-speed gearbox, and the automatic gearbox is there with the multi-speed gear operation, and CVT is also maybe there, but you will find in the future. Now this is a cooling system for EV. Now the question is that there is a no heat generation over here, no engine is there, so why we require a cooling system? So basically what happens, as we know that we are utilizing over here a variable frequency drive, and sometime what happens, high variable frequency drive as well as this battery, when we get a very high power very quickly for the acceleration purpose from the battery gets heated. Sometimes what happens, if we get a very high power from this particular battery, that controller might be heated. And if we supply this particular very high power to the electric motor, then electric motor might be get heated. So to cool down this particular component, majority in the case of battery and the controller, we required a cooling system. And this cooling system is nothing like but the cooling system like which we are equipped with the normal petrol and engine, diesel engine cars with the radiator. But the capacity of this cooling system is low as compared to the petrol and diesel vehicle, because the heat generation in case of petrol and diesel is very high as compared to electric vehicle. But electric vehicle requires some cooling. So if you consider that when you are using your mobile phone and you can feel that when you are charging your mobile, you might be feel that your phone is get heated. When you are using very high graphic games, playing your very high graphic games in your phone, then you can feel that your phone gets heated. So same way, these electric battery for batteries, when we are accelerating very rapidly and all these sudden cases, battery might get heated, and to cools down we required electric. Uh, so we can uh, the cooling system is there for the to cool down the battery as well as the controller, and in some case there motor too. So here you can see the comparison of electric diesel and petrol vehicle. So this is these details I got from the Tata Motors website, and you can see this the I have compared the automatic version of all three Nexons. First one is XZ Plus electric, XZ Plus automatic diesel, and XZ Plus automatic petrol. So you can see over here power. So 127 bhp in diesel, you will get 108 bhp. In the petrol, you will get the 118 bhp. So again, it is varying from the 110 to the 130 bhp torque. Over here you will get a 245 newton meter. Over here you are getting 260 newton meter, and over here 170 newton meter. And so weight of the vehicle is a 1400 kg, this is a 1305 kg, and this is a 1252 kg. So you can see this the petrol engine car vehicle is with the lowest weight. Over diesel engine vehicle is a 1305 kg, and from you will find that over here almost this is 100 or 95 kg heavier than the diesel engine. And if you compare a cost, then this electric vehicle Tata Nexon will costing around 16.25 lakhs. This diesel Nexon will cost around 12.70 lakhs, and this petrol is 11.04 lakhs. So you can find that, or you can easily compare these all three vehicles, that the electric vehicle is costlier and bulkier, but you are getting a maximum efficiency over here. So if we, in the current scenario, if you are concerned about the environment and all these things, then you definitely can purchase this particular vehicle. But if we are using a cost and not concerned about the environment, but if you are concerned about cost and your mileage, then if you are traveling almost 20 kilometers per day, then the petrol vehicle is beneficial for two. If you are running with the 30 to 40 kilometer per day, then the diesel engine vehicle is beneficial to you. And if you are your daily mileage is above 50 kilometers, then the electric vehicle is best for you. Now, selecting the right motors for the EV. For selecting the appropriate electric vehicle motors, one has to first list down the requirements of the performance that the vehicle has to meet, the operating condition, and the cost associated with it. For example, go-kart vehicle and two-wheeler applications which require less performance, mostly less than 3 kilowatt at a low cost, it is good to go with the BLDC of motors. For the three-wheelers and two-wheelers, it is also good to choose a BLDC motor with or without an external gear system. For high power application like performance two-wheelers, cars, buses, trucks, and the ideal motor choice would be the PMSM or induction motor. Once the synchronous reluctance motors and switch reluctance motors are made cost effective as PMMS or induction motor, then the one can have more options for the motor type of electric vehicle application. So this is from my side. Thank you very much.
Yes, sir. Thank you, sir. Yes, Dear students, if you want to ask something, you can write in chat box of FB so that I can ask uh, your question to the sir. Yes, sir. I'm not getting any questions right now on chat box.
Okay.
Okay, okay. Thank you, all of you, once again for attending this very informative webinar. Thank you, sir, for enlightening and informative presentations in a right way. And we appreciate you for taking time out of from your busy schedule. Thank you for your support. And yes, so here we are concluding our today's webinar. Thank you, all of you.
Thank you. On Kamal sir,
Yes, sir.
can I get the link of your FD live session?
Yes, sir. I will forward you. Yes.
Okay. Thank you. And can you share me the feedback of this webinar?
Yes, sir. Sure, sure.
Okay, thank you. It will helpful to me to improve my presentation as well as some content for the future.
Yes, sir. Sure, sure, sure.
Thank you. Thank you.
Thank you, sir.
So can I leave?
Yes, sir. Yes, sir.
Okay.